Welcome back. In the last video, we talked about query parameters and how to use them for searching. Today, we'll learn about pagination. Pagination helps us handle large amounts of data by breaking it into smaller, manageable pages. Ready to make our API even more powerful? Let's get started. In the last video, we added two query parameters to our getEmployee REST API, employee name and department. These let us filter the results and send back only the employees that matched our search criteria. Imagine we have over 2,000 employees in our database. Sending all 2,000 plus records in one go wouldn't be practical or efficient. It would slow down our application and overwhelm the user. Think about it like this. When you're shopping online, you don't see all the products at once. Instead, you see a few items at a time and click next to see more. We can do the same with our API using pagination. For example, let's say we show 2 employees per page. The user can navigate through pages to see the next set of employees, making the experience smoother and faster. Page 1 will show employees 1 to 2, page 2 will show employees 3 to 4, and so on. In today's video, we'll learn how to add pagination to our getEmployees API. We'll make our API return data in smaller chunks, and include information about the total number of pages and which page the user is currently on. Currently, our getEmployees API returns a simple list of employees. However, we can't include page details like which page the data is from and the total number of pages in this response. This information is crucial for the UI to enable or disable the next and previous buttons. For example, if there are 10 pages in total and the user is on page 10, showing the next button would be useless since there are no more pages to show. The user would be left clicking a button that doesn't do anything, which isn't a good experience. To make our API more user-friendly, we'll add pagination details to the response. This way, the UI can manage navigation buttons more effectively and provide a better experience for the user. So, we need to change the response of this API to accommodate these details. We'll include information about the current page, total pages, and the employees for the current page. Let's create a new class named EmployeeListResponse. Now, in the EmployeeListResponse class, let's add a list of employee to hold the employee details. We'll also add 2 more fields, current page number to track the current page, and total pages to know the total number of pages. This will make our response clear and helpful for managing pagination. To make our code cleaner and save time, we'll use Lombok annotations for getters, setters, constructors, and builders. This will make our EmployeeListResponse class easier to manage without writing all the boilerplate code. Next, let's update our getEmployees REST API. Instead of returning a simple list of employee, we'll change it to return EmployeeListResponse. Let's also update the response type of our service method to EmployeeListResponse. Add a new parameter, page number. It tells which page of employees to return. Let's update the getEmployees method signature in the EmployeeServiceImpl class to include the new page number parameter. Let's make our page size configurable by picking it from our application.yml. Define a variable PageSize in the EmployeeService class. Bind it using the @value annotation with the key employee.page.size. Open our application.properties file and add employee.page.size and its value to 2. In the getEmployees method, we already have our employee filtering logic in place, and it's working great. We're not going to change that. Instead, we'll enhance it by adding pagination to the filtered results. First, let's calculate the total number of pages. Get the size of the filtered employee list. Divide this size by the page size. If there's a remainder, add 1 to the total pages. We just calculated the total number of pages. Let's understand this with a simple example. Suppose we have 5 employees. And our page size is 2. On the first page, we'll show 2 employees, leaving 3 employees. On the second page, we'll show 2 more employees, leaving 1 employee. On the third page, we'll show the last employee. So, we end up with 3 pages in total when our page size is 2. Now, let's see how this works with the calculations. We have 5 employees and a page size of 2. Divide the total number of employees 5 by the page size 2. 5 divided by 2 equals 2 with a remainder of 1. Since we have a remainder, we need 1 more page to display the remaining employee. So, we add 1 to the total pages, giving us 3 pages. Now that we understand the total pages, let's move on to calculating how many records we need to skip to get to the correct page. This ensures we fetch only the records for the requested page. Now, let's calculate how many records we need to skip to get to the correct page. It's simple. Take the page number we want to return. Subtract 1 from it. Multiply the result by the page size. Open a stream on the filtered employees list. Use the skip method to skip the calculated number of records. Then use the limit method to limit the results to the page size. And collect the result. Now, let's create an employee list response object. We'll set the employees list, total pages, and current page number in this object. Now, let's open the employee controller class. Now, let's add another query parameter for page number to our getEmployees REST API. If we don't receive a page number in the request, we'll return the first page by default. Let's add the default value attribute to our @requestParam annotation with a value of 1. As you can see on my screen, we've been using a hash map to store employee details. Let's switch to a linked hash map so we can keep the order of insertion. This means our employees will be retrieved in the same order we added them, making our data more organized and consistent. According to our employee map, here's how the data will be paginated. On the first page, we'll see employees with IDs 1 and 2. On the second page, we'll see employees with IDs 3 and 4. On the last page, we'll have employee ID 5. Let's start the application. Open Postman. Let's test our new pagination feature. Let's untick the employee name and department filters we added earlier. Now, add page number in the Query Parameters tab, and set the value to 1. Then, send the request. As you can see on the screen, the response shows exactly what we expected. Employees with IDs 1 and 2. Current page number is 1. Total pages is 3. This means our pagination is working perfectly. Our API is returning the correct employees for the first page, and it's telling us there are a total of 3 pages. Now, let's set page number to 2 and send the request. This should fetch the next set of employees. As you can see in the response, this time we got employees with IDs 3 and 4. This means our pagination is working correctly, showing the right employees for the second page. Ready to check the final page? Let's set page number to 3 and send the request. As you can see in the response, this time we got employee with ID 5. This confirms that our pagination is working correctly, showing the right employee for the third page. Our pagination is working perfectly across all pages. To summarize, we added pagination to our getEmployees API. We tested our pagination with different page numbers to ensure it works correctly. We confirmed that our API returns the correct employees for each page, along with pagination details like current page number and total pages. Thank you for watching. In the next video, we'll dive into the post-HTTP verb and how to handle creating new resources in our API. Don't forget to subscribe and hit the notification bell so you don't miss any updates. See you next time.